All right, so we're going to go over this graphing quadratics review sheet. One of the things that we're going to look at are our vocabulary words and kind of how we're going to make sure that we understand everything. So you need to know what standard form is. I gave you a little word box here. And standard form of a quadratic function, the only one that even looks like an equation here is that one. Okay, so ax squared plus bx plus c. This is important because we use this later when we talk about the quadratic formula, when we talk about how c is our y-intercept, when we talk about how to take the axis of symmetry from an equation. So you do need to know how to do that. You need to know the formula. The shape of a quadratic equation is, and my guess would be most of you would put U-shaped, okay? But we're looking for the word that matches up here, and that's the parabola, okay? So that's the mathy, fancy word for how to say a U-shape. A lot of you are pretty good at that because you like the word parabola over quadratic, so you're totally okay. Number 3 is pointing to what we call a line of symmetry or an axis of symmetry. Okay, a line of symmetry or an axis of symmetry. I'm pretty sure the one up here says axis. I wrote line. That's okay. When I look at this line of symmetry, I would like you to fill in what it is. So I'm coming here. When I look at a line of symmetry, it hits my x-axis. So it's going to be an x equals, and you want to know when it hits the x-axis, which is right there, which is at -1, 2. -2. Okay. Then I put a little blurb right here asking about this point. This point is a special point. It's called our vertex. My vertex here is at -2, comma, -2. In my class, you're not going to get full credit right now with what you have. You would need to go and put parentheses around those. Okay, so we've got to be really careful. We got to make sure that we know when something's a point that gets parentheses and when something is multiple points just written next to each other, or when something is a point that only needed one number, so it didn't need parentheses, so on and so forth. When the vertex is at the highest point on the graph, we call that a maximum. Okay, a lot of you have past background of that. That's a max. And when it's at its lowest point, it's called a min. Okay. Our solutions. I haven't used this word like very often. Our solutions are the same thing as roots, which are the same thing as x-intercepts, which are the same thing as zeros. So all of these words mean the same thing. We use them in different contexts under different equations, okay? So roots is going to be something that you see a lot in Algebra 2 trig. Zeros, again, I see those a lot in Algebra 2 trig. I see them a lot in pre-calculus called zeros because we literally set it equal to 0. We use that zero product property. So the word zeros is a really nice one. Solutions is really nice because it's like the answer to your problem. Roots are nice because usually we have to square root to get there at a certain point in time. Right now we're not doing things that difficult. And then x-intercepts are nice because it's like where it is on the graph. So each of those words has a reason for its name, and it's fine. It doesn't matter which one you use as long as you can interchange them. Okay, so again, I would write x-intercepts one more time, because this is my favorite one. This is the one I've been using a whole bunch. So it says, how many roots are there? How many zeros are there? How many x-intercepts are there? What is the number of? Right now, I'm only seeing it cross here. It crosses once. And the number it crosses at is 3. Right here, I don't see that touch my graph ever. Okay? It never touches my graph. If it never touches my graph, there's no roots. This is not possible for you to give me a 0 right now. Okay? They're what we call imaginary. Okay. This one right here, if I draw a line through, I hit twice. Once at the origin, so once at 0, and once at -2. There were 2 real roots here. These zeros, they don't get parentheses, okay? This represents 2 different points on my graph right now. So, if I'm given the following graph, can I find the axis of symmetry? This is just you cutting your graph in half, so that should be pretty easy for you to draw. The problem is here is that a lot of you get here, you read the words, and you go, I don't know. What do you mean you don't know? Okay? I ask you, can you draw it? And you do perfectly fine. You can draw it. Okay? You need to get to the point where I don't have to ask that anymore. So I draw my axis of symmetry. I would ask you, does it touch the x-axis or the y-axis? You would tell me it touches the x-axis, Ms. Storker. I would ask you, okay, where does it touch the x-axis? And you would tell me at 3. So I get x equals 3 is my line of symmetry or my axis of symmetry. A vertex. The vertex is going to be the very top of my graph or the very bottom of my graph. In this case, it's the very bottom of my graph. A lot of you are actually still really struggling with this vocabulary word. The vertex in our absolute value was that bottom of the V. Okay? It represents the same sort of thing here. It represents where that curve takes place. It really is, it's the most important point on the graph. It's the one that's weirdo schmeardo. It's the one that doesn't mirror because it mirrors itself. So that's something that we need to get familiar with. We need to start learning those vocab words. Okay, so a vertex. This is located at +3. Do you see how that x was really the x of my vertex? It was really the x of my vertex. Okay. My vertex was -3, or was at 3, and then I go down 1, 2, -2. Okay. So how many zeros are there? How many x-intercepts? That's how I'm going to ask the question. How many x-intercepts are there? There's 1, 2 of them. Where are they located at? Well, they're located at +2 and +4. Do I need to put parentheses there? Absolutely not. This represents 2 different separate points. I do not put parentheses there. I put parentheses on my vertex because my vertex is 1 point. It represents just that piece. Domain and range. So my domain represents my x's. My x's are how far to the left does this graph go and how far to the right does this graph go. And some kids are like, it goes to -2 and it goes to +8. No. Okay. So then they go, okay, so I guess the last point here was at 1, and I guess the last point here was at 5, so it goes from 1 to 5. No. The graphs that I give you in class have these arrows on them. The arrows mean that they go on and on forever and ever and ever. And since these arrows are going like a little bit diagonal, it means that it goes on forever that way and that way. Forever that way and that way. Okay, in the directions that it points. So that's really important for us to understand. So that means my leftist point here is actually negative infinity. And my rightist point here is actually positive infinity. Both of these get parentheses. The reason why these get parentheses is because these are like circular shapes. I need that circular parenthesis. Okay? Some of you are really struggling with this still. Infinity, we never know what that equals. If you know what infinity equals, you need to go and get yourself a Nobel Prize. Okay? My range. My range represents my y's. That's how far up and down it goes. The weird thing is in English, we always say the up first instead of the down because we assume that we start at the down to begin with. So like when you jump, you started at the down, but we don't have to say anything about that because we already assume it. In math, we do have to start from the down. So my farthest down point is -2. My farthest up point is that positive infinity. Infinities always get parentheses. The -2 has a solid line, a solid dot. It gets that solid bracket. Okay. So we're going forward to graphing quadratics. There's a couple of like tips here that you could go through and read, but I'm going to go ahead and I'm going to do these with you. So my question to you would be, what form did I give this to you in? And this is in standard form. A lot of you have no problem pointing this out to me, but when I give you my quiz that says, give me standard form, you went, I don't know what that is. I don't know what to do. Guys, it was free points. Free points. There's your standard. You know it. Okay? So don't get so scared. Slow down. Go see what you can do one piece at a time. So this is my standard. From standard, there's a really easy thing for me to get. And my really easy thing for me to get is my y-intercept. My y-intercept is always that last number, -3. Okay. Now, almost every time I've given this to you, I've asked you, does it factor? So you go, do I have a GCF? No. Okay, I'm going to try the x. So I get -3 times 1. That 1 came from the secret 1 that tells you there is 1x squared there. So -3 goes on the top, and -2 goes on the bottom. I have -3 and -2. What multiplies to -3 and adds to -2, -3, and +1. Here's where I go through and I do my box. Okay? My box, I get x squared on the top. I get -3 on the bottom. Those were the easy pieces. I'm going to stop my video here. I'm going to let you mull it over for a little bit, and then you can click on the next one.